Imagine running your hands through the softest, most luxurious wool you've ever felt. That's the magic of merino wool, a favorite material loved by millions around the globe. But have you ever wondered how this amazing fabric makes its way to you? Join us in exploring the journey of merino wool, from the wide open fields of Australia, where over 78 million sheep roam, to the very tips of your fingers. We'll see the hardworking folks who gently shear the sheep, turning their fleece into a valuable material. Then we move to the busy factories, where this raw wool is carefully processed into the soft, cozy fabric you love. Prepare to be amazed as we dive into the big and exciting world of sheep wool production. In today's wool industry, the shearing of sheep blends old methods with new technology, leading to better efficiency, welfare for the animals, and safety for the shearers. This change is part of a larger move towards sustainability and ethical practices. Transitioning from manual hand shears to machine shearing has marked a considerable advancement, offering a quicker and less stressful method for wool removal. This not only accelerates the process, but also minimizes the risk of injuries to the sheep, highlighting an emphasis on animal well-being. Further innovation is seen with the development of a non-mechanical shearing method by C0 in Australia, which uses a protein injection to naturally separate wool fibers. This technique represents a significant step towards reducing animal stress during the shearing process. In colder climates, the resurgence of blade shearing reflects an acute awareness of animal needs, as it allows sheep to retain some wool for insulation. Despite being more time-consuming, this method underscores the industry's dedication to ensuring animal welfare and embracing sustainable practices. Technological advancements extend to shearer safety as well, with research into wearable robotics aimed at preventing back injuries by enhancing posture. The introduction of shear jitsu, which emphasizes proper body mechanics over physical force, serves to make shearing more accessible and reduce the risk of injuries, further indicating the industry's focus on safety and inclusivity. As the industry looks towards the future, the exploration of automation and robotics presents a promising avenue to streamline the shearing process, improving safety for both animals and shearers while maintaining wool quality and reducing operational costs. Although fully automated shearing systems have yet to become commonplace, these advancements signify the industry's ongoing efforts towards innovation and continuous improvement. After wool is sheared, the examination and preparation are done to meet high standards and fulfill consumer demands. This process, essential for determining the wool's final quality and use, involves skirting, grading, and sorting in modern facilities. Skirting is the first step, where each fleece is spread out and inspected to remove the dirtiest parts, usually from the underbelly and rear. This part of the wool, called grease wool, is rich in lanolin, a natural oil that protects the sheep's fleece. Although not pristine, this wool is valuable and set aside for various uses based on its quality and condition. Next is grading, a critical evaluation of the wool's fiber thickness and cleanliness. This stage sorts the wool into quality categories, guiding purchasers in finding the wool that best suits their needs. The most precise and common method for grading is the micron system, which measures fiber diameter in microns, allowing wool to be classified into specific ranges for different product qualities, such as softness and durability. Sorting them meticulously divides the wool based on characteristics like length, fineness, and texture. Wool is categorized from the shoulder's finest fibers to the lower leg's coarser ones. This detailed separation ensures wool matches appropriate manufacturing uses, from high-quality garments to more rugged materials. Advancements in technology, including optical and laser scanning, have modernized these processes, ensuring consistent quality and efficiency. These innovations, coupled with expert handling, ensure that wool's value is maximized, supporting a range of products from luxury apparel to everyday items. The contemporary technique of cleaning raw wool, known as wool scouring, integrates advanced methods with a focus on environmental sustainability. This crucial initial step involves using water and eco-friendly detergents in vast industrial containers to eliminate lanolin, dirt, and other impurities, transforming the wool into high-quality, clean products. During the scouring process, wool first undergoes a preparation phase, where bales are opened and possibly mixed to ensure uniformity across batches. It then travels through multiple washes with water and specially chosen detergents that clean without damaging the fibers. Mechanical action in these baths aids in loosening and removing dirt and oils. The selection of surfactants is vital. They must cleanse effectively while being gentle on the wool. Following the cleaning stages, the wool is thoroughly rinsed to eliminate any lingering detergent and impurities. This washing and rinsing cycle is carefully managed to ensure the wool's purity and fiber integrity. After being cleaned, the wool is dried and subjected to quality checks to confirm it meets stringent standards. In line with growing environmental awareness, wool scouring practices have evolved to incorporate water recycling and wastewater treatment technologies to lessen water use and prevent pollution. This approach demonstrates the wool industry's commitment to reducing its environmental footprint. An interesting byproduct of scouring is lanolin, a natural oil prized in cosmetics and other industries. Recovering lanolin adds value by finding uses for what would otherwise be waste and exemplifies the wool industry's efforts towards achieving a circular economy. Technological advancements have notably improved the scouring process. Innovations in detergent chemistry and mechanical processes allow precise control over scouring conditions, such as temperature and agitation, optimizing cleanliness and efficiency. These improvements have enhanced the wool's quality and sustainability, making a significant step forward in wool processing techniques. Once the wool is thoroughly scoured, drying it properly is crucial to make it suitable for subsequent steps without compromising the fiber quality. The process begins with mechanical methods, like squeeze rollers, to gently press out the bulk of the water, ensuring the wool's structural integrity remains intact. Following this, hot air dryers come into play, carefully evaporating the leftover moisture. This phase is delicate. Excessive heat or improper handling could damage the wool fibers, potentially degrading the final product's quality. Cutting-edge drying technology is central to this stage, employing precise control over temperature and airflow to achieve uniform drying. These systems are thoroughly calibrated to dodge the risks of wool shrinkage or fiber damage, safeguarding the wool's pristine condition and preparing it for its transformation into various woolen products. Environmental sustainability also takes center stage in modern wool processing, extending into the drying phase. Initiatives and guidelines, such as those from the Woolmark Learning Center, stress the importance of efficiency and environmental mindfulness in wool scouring and drying. Efforts are made to ensure processes are not only practical but also environmentally friendly, with a focus on minimizing the ecological footprint. This includes optimizing energy use and managing byproducts and wastes to lessen pollution and promote recycling. The detailed approach to drying, combined with a commitment to sustainability, illustrates the wool industry's dedication to preserving the quality of the wool and the environment's health. By integrating advanced drying technologies and sustainable practices, the industry ensures that wool remains a valuable and responsibly produced material, ready for its next stages in textile manufacturing. Following the thorough cleaning of wool in the scouring process, the drying phase is paramount to ready the wool for additional steps without harming the fibers. This phase typically unfolds in two primary stages. First, mechanical methods are employed to expel excess water, and then hot air dryers complete the drying. The process begins with squeeze rollers, which exert pressure on the wool to squeeze out water mechanically. This method is gentle yet effective, significantly lowering the wool's moisture content without introducing heat that could compromise the wool's natural characteristics. After mechanically removing the bulk of the water, the wool is introduced to hot air dryers. These systems, equipped with precise controls for temperature and airflow, ensure the wool dries uniformly. Such meticulous regulation is essential to avoid the risks of overheating, which could shrink or damage the wool fibers. Uniform drying is key to preserving the wool's quality and making it suitable for the next steps in its transformation, such as carding and spinning. During the drying phase, emphasized by the Woolmark Company in the wool scouring process, wool undergoes cleaning with detergents and is then thoroughly dried. This step is critical for eliminating contaminants and preparing the wool for subsequent manufacturing processes. Key concerns during drying include avoiding entanglement and preventing felting. If not properly addressed, these issues can lead to fiber breakage in later stages of processing, adversely affecting the efficiency and quality of the final wool products. This highlights the importance of carefully managing and drying process to maintain the integrity and quality of wool fibers for their various end uses. The scouring and drying process aims to remove nearly all contaminants while maintaining the wool's integrity, ensuring it is in the best possible condition for efficient and high-quality processing into finished goods. Carding marks a crucial phase in wool processing, where the aim is to disentangle wool fibers and clean them in preparation for spinning. This stage not only separates the fibers into single strands, but also removes any lingering impurities, rendering the wool pristine and ready for further processing. The essence of carding lies in its ability to break apart clumps of fibers, align them more uniformly, and eliminate contaminants like vegetable matter, dirt, and dust. Moreover, carding distributes the fibers evenly, enhancing the consistency and the quality of the yarn that will eventually be spun. Carding machines today are sophisticated and equipped to handle wool meticulously. They feature large drums outfitted with fine, wire teeth that carefully comb the wool. These drums rotate at varying speeds and directions to perform mechanical actions on the wool, including combing, carding, and condensing the fibers into a web or sliver, tailored through specific pin configurations for optimal processing. The carding journey begins with the wool passing through a picker, which reintroduces air into the material and starts loosening any entangled vegetable matter. This preliminary step is essential to prepare the wool for the main carding stage. Following this, the wool encounters the carding machinery, which systematically combs through the wool, progressively refining it, removing plant matter, and discarding shorter, weak fibers. The efficiency of this process is significantly enhanced by synthetic lubricants and water, which minimize friction and static, thus improving the carding quality. Innovations in carding, like those adopted by facilities such as the Wool Gatherer Carding Mill, emphasize advanced machines that sustainably extract vegetable matter without resorting to harsh chemicals. This modern approach underscores a commitment to environmental sustainability and assures that the wool, especially in products like organic bedding, meets the highest quality standards. Combing wool, although not always required, plays a vital role in the wool processing chain, particularly when producing finer, smoother, and more durable yarns. This step comes after the initial shearing, washing, or scouring, and wool carding. Carding serves to aerate, detangle, and open the wool fibers, setting the stage for spinning. Combing then takes over, passing the fibers through a series of combs that align them perfectly and are increasingly fine, aiming to eliminate short fibers, known as noils, and any remaining impurities like vegetable matter or knotted fibers, neps. The outcome is a combed wool sliver primed for spinning into yarn. Combing is pivotal for creating worsted wool yarn, which is noted for its smoothness and strength compared to the loftier and airier carded yarn. This process compacts the fibers, removing the air introduced during carding, and results in a yarn that, while less warm, is more resilient to wear and tear. As such, worsted wool is known for its uniformity, enabling crafting of extremely fine and precise knitwear and woven fabrics. This characteristic renders combed wool especially sought after in the luxury market, finding applications in upscale clothing and furniture. Though combing is optional, it significantly elevates the wool's quality, cleanliness, and readiness for further manufacturing processes, such as spinning, dyeing, knitting, or weaving, tailored to the end product. It's noteworthy, however, that combing may lead to a loss of up to 15% of the carded wool, which, while beneficial for yarn quality, also escalates production expenses. This loss and the added processing time and material wastage render combed yarns pricier than their carded counterparts. The spinning of wool into yarn transforms the prepared wool fibers into a cohesive and continuous thread suitable for various applications. This process leverages traditional methods and modern innovations to meet the demands of quality, efficiency, and sustainability. Two primary spinning methods are utilized in the wool industry: worsted and woolen. The worsted method focuses on producing finer, smoother, and stronger yarns by combing the long fibers to align them parallelly and tightly twisting them to create a dense and smooth yarn. This technique is ideal for producing high-quality fabrics for formal garments due to the yarn's fine and smooth characteristics. On the other hand, the woolen method produces yarn that is generally coarser, with a more varied fiber alignment and a softer finish. This method includes ring and mule spinning techniques unique to the woolen industry. The woolen spun yarns are perfect for creating warmer and bulkier fabrics like sweaters and blankets due to their airy structure and insulating properties. The advancements in spinning technology have introduced several innovations aimed at enhancing productivity, quality, and environmental sustainability. The Shima Seiki whole garment innovation allows for the creation of performance wear, which is particularly beneficial for mountain and snow sports by integrating cutting-edge knitting technologies. The Gina Logia Wool Up is an eco-friendly process that makes wool garments machine washable using an ozone treatment, reducing water, chemical, and energy consumption compared to traditional shrink-proofing processes. 3D printing on merino wool presents a breakthrough in textile design, offering flexible design possibilities and infinite potential for high-end fashion by printing directly onto base fabrics. Digital printing offers increased design flexibility and waste reduction by allowing direct printing on wool fabrics, opening new market opportunities for wool fabrications. Natural coloration technology utilizes natural dyes, which are absorbed better by wool than synthetic fibers, to produce a superior natural aesthetic quality. The Optim spinning technology is a chemical-free method to create wind and water-resistant fabric made with 100% merino wool, showcasing wool's versatility as an eco and performance fiber. The process of dyeing wool involves several stages that can significantly impact the yarn's color, strength, and quality. Understanding these processes and integrating sustainable practices is crucial in minimizing environmental impacts while meeting consumer demands for eco-friendly products. Wool can be dyed at various stages of its processing, from loose stock, top, and yarn to fabric and garment. Each stage offers unique advantages and challenges, with dyeing after spinning being particularly effective for achieving uniform color distribution. This uniformity is crucial for ensuring consistent quality across textile products. The preparation of wool for dyeing, selection of dyes, and the dyeing machinery used are all critical factors that influence the outcome of the dyeing process. Moreover, evaluating the fiber's appropriateness for specific dyeing operations helps maintain the wool's desired quality and characteristics. Sustainability in wool dyeing is increasingly becoming a focal point, driven by environmental concerns and consumer demand for sustainable products. Emerging technologies and ecological approaches to textile dyeing pave the way for more efficient and environmentally friendly dyeing processes. Plasma technology offers an effluent-free and environmentally friendly process by promoting surface modification of textile substrates, thus increasing dyeability and reducing water, chemicals, and energy use. Supercritical CO2 dyeing utilizes supercritical carbon dioxide as a swelling agent during dyeing, significantly reducing energy consumption compared to conventional methods. Air dye technology is a sustainable solution for printing and dyeing that uses sublimation to transfer inks to fabrics, significantly reducing water usage, energy consumption, and emissions. Ultrasonic dyeing enhances the dispersion and diffusion rate of dye or finishing chemicals inside the fiber, offering a rapid dyeing rate and increased efficiency. Microwave technology provides uniform, rapid, and effective heating, which improves the exhaustion rate, dye diffusion, and color fastness properties. These technologies and natural dyes obtained from plants, bacteria, mushrooms, and fungi represent a significant shift towards more sustainable and eco-friendly wool dyeing practices. Not only do they reduce the environmental footprint of the dyeing process, but they also offer the potential for creating textiles with unique aesthetic and functional properties. The integration of sustainable practices in the wool dyeing process underscores the textile industry's commitment to environmental stewardship and innovation. As consumer awareness and demand for sustainable products continue to rise, adopting these innovative dyeing methods will play a pivotal role in shaping the future of the wool industry, balancing quality, performance, and environmental responsibility. The textile industry has undergone remarkable transformations with the introduction of advanced weaving and knitting technologies. These innovations have opened up possibilities for creating fabrics with unmatched precision, efficiency, and complexity in design. Such advancements not only allow for more intricate patterns and designs, but also contribute significantly to sustainability and efficiency in fabric production. A prime example of these advancements is Shima Seiki's whole garment knitting technology. This innovative approach to garment manufacturing marries technology with customization, allowing for the creation of clothing that fits an individual's exact measurements. Through the use of a smartphone app, a person's body can be scanned, and the data covering aspects like the garment's size, length, sleeve length, and color is then sent to a server. This information automatically adjusts the settings on the Mach 2XS103 whole garment knitting machine, which then knits the garment in its entirety. This technology not only streamlines the manufacturing process, but also significantly reduces waste by eliminating the excess material typically left over from traditional garment production methods. The move towards mass customization, as exemplified by Shima Seiki's technology, showcases the textile industry's commitment to innovation, sustainability, and meeting the personalized needs of consumers. Yarn Bank, another Shima Seiki innovation, is a platform for searching and downloading digital yarn data, which can be used for virtual sampling. This reduces the need for manual yarn scanning, enhancing simulation accuracy and product planning efficiency. It connects yarn companies, apparel companies, and knit manufacturers digitally, providing a new sales channel for yarn companies. H. Stoll AG & Company, KG's Knittelligence Machine Generation represents a leap towards the digitalization of the knitting process. It automates processes to facilitate work, offering more transparency, shorter response times, and higher productivity. The technology integrates functional aspects like breathability and stretch with design requirements in one knitting process. Vanguard Pai Lung, a leading manufacturer of circular knitting machines, introduced the Manufacturing Execution System MES, a knit monitoring system designed to schedule, monitor, and manage knitting operations. This system allows remote access, providing control over the knitting plant anywhere. It alerts operators when parts need to be replaced, enhancing efficiency and reducing downtime. Pai Lung Machinery Mill Company Limited's advancements in circular knitting technology include the development of spacer fabrics, which have revolutionized the fabric industry by offering an alternative style for padded bras and other apparel. Their specialized flat spacer machine ISP203 can knit a single piece of spacer fabric with varying thickness, demonstrating the versatility of modern knitting machines. These advancements in weaving and knitting technology, coupled with the integration of computer-aided design CAD software, have significantly impacted the textile industry. CAD software enables the creation of detailed patterns and the adjustment of machine settings to achieve specific fabric characteristics, allowing for greater creativity and efficiency in fabric production. The combination of advanced machinery and CAD software enhances the design and manufacturing process and supports sustainability efforts within the industry. By enabling mass customization and reducing waste, these technologies contribute to creating eco-friendly and high-quality textiles that meet the demands of modern consumers. The final steps in the wool processing chain are finishing, quality control, and implementing sustainable practices, which are critical in defining the quality, appearance, and environmental impact of wool products. In the finishing phase, the fabric receives its final touches to enhance its texture, appearance, and durability. This involves several treatments, such as washing to remove any remaining impurities and prepare the fabric for further processes, shrinking to control the fabric size for stability during use and care, and softening to improve the hand feel and comfort against the skin. Innovations have emerged in finishing techniques to achieve these effects without harsh chemicals. Enzyme treatments use biological catalysts to soften the fabric and improve hand feel, while mechanical brushing raises the surface fibers to make the fabric softer and fuller. Throughout wool processing, rigorous quality control measures are essential to ensure the final product meets industry standards and consumer expectations. This involves testing for fiber strength, color fastness, and the overall feel of the fabric. Sustainability is a key focus, with the industry adopting more eco-friendly practices such as using renewable energy sources like solar and wind to reduce carbon emissions, implementing water recycling systems to conserve this critical resource, and strategies for minimizing waste, including reusing or recycling byproducts like wool grease extracted during scouring. The wool industry is dedicated to enhancing animal welfare standards and improving traceability. This commitment enables consumers to understand the origins, processing methods, and the journey of their wool products. By integrating time-honored techniques with contemporary technological advancements, the industry places a strong emphasis on environmental stewardship. This comprehensive approach ensures the high quality of wool products while aiming to minimize environmental impacts and promote ethical practices throughout the supply chain. Thank you for joining us on this exploration of modern sheep wool processing. If you're interested in staying updated on our videos, don't forget to subscribe to our channel and browse through our collection for more insightful content. Until next time, thanks for watching.